right, I hope you guys are having a great week. We are going to look at ionic and covalent bonding together. And so here's the link to that, to the worksheet. Now you guys will have this printed out. Let me go to the website. Now you can get to the website through there, or where'd I put it? Go to the link. Or you can click on it from there. Either way, it doesn't matter. All right, so once I am there on the website, let's just kind of look at this. It says, I'm going to do the pre-virtual lab questions with you. So if I'm going to quickly, just pause the video and then come back to it when you're ready. So number 1 says metals are located on the right/left, circle one. My metals are like iron, copper, sodium. All of those are metals. So those are on my left side of my periodic table. And then it says my nonmetals are located then on the right side. And that's like your oxygen gas. Now remember, we have that one exception, which is hydrogen. Hydrogen is found on the left side, but he is our exception. Or I call him a he. Number 2, what subatomic particles participate in chemical bonding? Well, yesterday, the previous 2 days, when you moved atoms together, those little tiny balls that were flying around, those were electrons. So that is the subatomic particle that has participated in chemical bonding. It's called electrons. Okay, they're the reason why we have reactions, why things might explode or be volatile. All right, so let's go to the virtual lab. So I'm going to kind of walk through this first one with you, and then you guys can kind of go from there. So it says choose sodium. So I'm going to go over here. Let me pull this down. I'm going to click on sodium, which is Na, and this box pops up. Now, this is going to help you answer these questions. What type of element is it? Well, you're going to find that element type is a metal. Okay, so that's what you're going to write down for that metal. How many valence electrons does it have? Valence electrons are the outermost electrons. Now, those are the ones that we care about. The ones that are in the inside on these other energy levels, their energy levels are complete and they're not reactive. It's these outer ones we have to worry about. So we will, instead of having to draw all these circles, and I'll show you what I mean here, let's do Bohr model. I'm going to do Bohr model. You'll go to images. Now, instead of doing, like, for instance, this one, look how many circles there are. There's 1, 2, 3, 4. We could have a 5th circle. Instead of having to, for instance, like on this one, instead of having to draw all of this out, they will just show the last 3, this outer ring. So it would be aluminum, and there would be 3 electrons around it. So I don't know if it'll let me do aluminum. It won't let me click on aluminum here. But if I clicked on aluminum, it would have 3 dots around it. Those would be its valence electrons. So, for example, sodium has 1 dot, so it has 1 valence electron. Now, I'm going to choose, number 2, choose fluorine. So I'm going to choose fluorine. So I'm going to answer those questions. And it says, what type of element is it? Let me scroll up here. Element type, non-metal. It's going to ask how many valence electrons there are, and there's 2, 4, 6, 7 valence electrons. And so then it says, what kind of bond is this? Well, on our periodics tables, I told you, and on the big one up on by my desk, my computer, there's a red line that kind of zigzags down through like a stair step. If it is a metal, something on this side, and a non-metal, like sodium and fluorine, it is going to be an ionic bond. So I'm going to click ionic. And if you get it wrong, obviously it'll tell you got it wrong. You need to click on ionic. So then it says, based on your knowledge of each of these atoms, predict the number of each atom. Now, if you look at this, sodium really wants to get rid of an electron, and fluorine really wants to get one to make. So if sodium gets rid of this, it's now full. Its shell that's below this is full. If it gets rid of this electron and gives it to fluorine, fluorine's now full. They're both happy. So they really just need one of each. This is almost like what we did last week when sodium would have one hand and fluorine would have one hand. Sodium would have a hand with an electron on it, and sodium would have an empty hand, like, give it to me. Another way to look at this is look at this. Sodium, I always said, remember, they all want to be like this last column. So sodium could either go 1, 2, 3, 4, 5, 6, 7, and gain 7 electrons, or it can go backwards to be like neon. It just has to go back 1. It's going to be easier for it to go back 1 and give up 1 electron. And if you look at fluorine, fluorine wants to go 1. So 1 and 1, that's all you're going to need is 1. Sodium 1. And I'm going to show you what happens if you click on the wrong answer. If I click 2, I'm going to submit my answer knowing that this is wrong. It tells you it's incorrect. Try again. So I'm going to click 1, and when my answer is correct, it's going to play this video. And it plays it over and over for you, okay? Now we need this video to answer the next questions. It says, answer the question on the screen. What type of bond is this combination likely to form? Ionic. Choose the appropriate number. We did that 1 and 1. Now 4, watch the animation closely. Describe the change in the number of valence electrons in the atoms as the bond is successfully formed. So if I explain this, let me go back to it. I can say sodium gives its valence electron to fluorine to make it full. That would be my explanation. What does the positive charge indicate? Well, it indicates that sodium, remember, electrons are negative. It lost a negative electron. That's why it's positive. That's why fluorine's negative. It gained a negative electron. So that was letter C. So B is it lost a negative electron and it became positive. C, it gained a negative electron to become negative. So what is the final overall charge of the compound? Well, let's look. Here we go. +1, -1. The overall charge is 0. And that's what we want. We want our charge to be 0. Okay, so overall charge is 0. What is the name and formula? Well, they will give that to you right here. The formula is NaF, and the name is sodium fluoride. All right, so that is how you are going to use this. Now, when you get down here to this chart, you're then going to do sodium and oxygen. Now, to get back to normal, you're going to click this little blue arrow. It's going to reset everything. So to fill out this chart, we're going to use sodium and oxygen. So I'm going to click on sodium. I'm going to click on oxygen. I'm going to fill this out. So you would be filling out, you'll be looking at the picture, how many valence electrons, what's the charge, which it'll give it that to you here in a second. Same for oxygen, number of valence electrons, what's the charge. The formula and the name we know is at the end. So here's the thing. Let me see here. Do you see where, look, this 1 electron could go right here, but oxygen still needs another one. So oxygen needs 2 sodiums. So it needs to be 2 sodiums for every 1 oxygen. All right, so once they do that, it's going to walk through, it's going to give you all of this. Now, when it says ion charge, that is for a single sodium. A single sodium is a +1. Don't tell me +2, that's for 2 of them. A single sodium is +1. All right, so that should be it. The rest, yeah, the rest is fine. I think you'll be fine on the rest of it. All right, so it's walking through, doing the exact same thing. When you're done with this one, you'll click the reset button, and it'll take you back up here. All right, if you have any questions at all, let me know, and I will help you out. Again, with this, if you please try to, if you need help from somebody or from me, let me know. But if you could take a picture of this, submit it, go onto this assignment, upload those pictures and submit it to me. That's going to help me out a ton. If we are now to, this would be Thursday? Yeah, we're on to Thursday and I've not gotten anything from you, I'm probably going to be reaching out to you. All right, so let me know if you need anything. Have a wonderful rest of the day, and I will see you next week. Bye.